Start.
Okay, so today we are discussing, a distributed logging system at an enterprise scale level for collecting and monitoring logs in, one centralized place. So this is more about the systems like, Splunk or New Relic. So these are the system basically, at the enterprise level, we deployed for collecting the logs at the centralized place. So I will try to, explain a bit about how the Splunk and New Relic works. So before that, I will go ahead and start, capturing the functional requirement. So
Hello. Is it breaking for everyone or it is
yes,
just me?
Pratik. Hmm. Pratik, am I clear? Or
Hello. I don't know. It is breaking for me. Is it audible to everyone?
It's clear for me.
It's clear for me, Pratik.
As well, share.
Yeah, it's clear for me.
Are you guys able to hear?
Yes,
Hello. Is it breaking for you, or you're able to hear him properly?
I'm able to hear him clearly.
Okay, cool then. Okay. Yeah, go ahead, Samar. I think I'll rejoin. Yeah, yeah,
yeah.
continue.
So the some of the core functional requirement I want to, pull it out here. Maybe I will write it down. The system should be, able to ingest logs in real time from multiple sources. So here our sources, could be the microservice-based architecture or any sort of, tools or applications which are continuously, flushing the logs to their, internal memory buffer. So those are considered as a source. I will write down some examples like microservice-based, system. Any tools or internal application. So we will consider the system should have capability to, collect those logs in real time. I will go ahead and consider, batch jobs as well. So batch jobs is the use case where the, the machine which is producing the logs will goes, offline because of, certain issues. Okay, so the logs goes in case of batch logs, we will store the logs in the local DB, the upload to the system when online, and we can schedule a job or whatever be the configurations, right? Batch jobs will support system DB, or maybe not. We can schedule the job, schedule the jobs, schedule the job to upload, or we can, set up any other configuration as well. The system should, have the capability to validate and parse and normalize the logs, which is, incoming to our, systems from the clients. And create a, standard structure before storing, in a persistent storage. So one more use case I would like
Increase
to
the
provide is
file
like, as we are considering the system is very much similar to, Splunk or New Relic, we need to provide a dashboard to the, set of users who can, and the flexibility, like they can easily search the system to, find if there is any problems or they want to query something. Okay, so we'll provide a dashboard to query, query the logs. So I would go ahead and try to, explicitly specify this one as, real time. So these are the couple of key functional requirement I'm thinking to be, we'll discuss all together. So I'm thinking if anything, major I would like to add, you guys can, provide your input. That will be helpful as well.
I think one factor will
alerting
be
is one, right?
log retention. So you need to give more of the customization to individual
Durability,
services.
durability, right? I will bring that one as part of NFR, the quality of system.
As part of functional requirement, maybe alerting as well, if time permits.
Come again, Pratik?
Alerting.
Okay.
Alerts.
So I will specify, some critical alert we need to broadcast to the external system or downstream system who are, who are publishing the logs to those system who are publishing to the logs, or any other system, any other downstream system will provide a critical alert to them. Will broadcast a critical alert. Okay, something like broadcast or
Also, I would like to just add here, if you can just briefly explain, if you know it, otherwise I'll add, like what is the difference between observability and monitoring, because these are the two terms which people kind of sub, right? That maybe you can write. And also, if we can write down some of the tools, right? Because we have a lot of people here, right? So we would like to know that what are the tools that they are using in their companies, right? So that will be also beneficial for us, all of us. Just add a point, no, that's it.
yeah.
Two things I said. 7 is the difference between observability versus monitoring.
One is the query
And
pattern
the
to look
tools.
into. Sorry, yeah.
7th is observability versus monitoring. And then 8th, you can write as the tools, with the various tools around this observability and monitoring.
Okay, yeah. So you mean like, what are the real-time tools we use in case of a distributed logging, right?
Yes. So not everyone has used everything, right? Somebody's in some places use, some people are using Grafana, some are using
Right.
Kibana, something else, right? Some people are using Datadog, right? So it'll be good to get their insights as well.
Yeah. So I have explicitly specified, right, a Splunk or New Relic is the, distributed logging systems, which basically, enterprise-based company, they onboard those systems. So is there any other, tools which is similar to Splunk or New Relic? I can go ahead and list it out here.
Yeah, I mean, no, we'll just probably end at the end of the session, right? We'll just ask everyone like what is that they are using, right, in their companies. So it'll give us a insight, right? We'll be able to compare the good or the bad things, right? Good or the bad features. I mean, a kind of a comparison between different tools. You don't need to. I mean, this is not an action item on you.
Hmm. Yeah, I know a couple of systems. Maybe don't call me on the spelling. Actually, this is Grafana. We have, those are monitoring tool. I will go ahead and write some of the tool I know. Is there log aggregator? Yeah, these are the tools I have worked also before. So for monitoring purpose, and these are the log aggregator tool basically, and these are very much popular. Okay, anything else we can add it, at the end. So I will go ahead and try to capture the NFR, which is the quality of the system we will discuss. So I will, one of the key NFR is the latency. So, so low latency, processing of the logs to our system in near real time. Okay. Latency, I can specify, as low as possible. Possible. I will quantify somewhere like each event. What could be the right number? Per event, we can, log in 1 millisecond per event. Does it make sense? Or we need to do a math per event?
I feel that's very, very, very low.
Yeah.
Right? But yeah.
It's a per event.
Let's
I
see.
mean, when I say event is like one log, which will contain, some timestamps and with some information. Okay, so like just 1 million of events, even 1 million events can get ingested in a second. I will consider like in something like 5 minutes here. That makes sense. So I will consider the system as high availability rather than consistency. The system should always available for ingesting the content. There is ingesting the content as soon as possible and available across multiple nodes for um, for for maintaining the high availability system.
The same applies also to the tools on the log discoverability also, right? Like the tools, whenever they query they use the queries, how fast they can get the logs.
Yes. So you're right. Thanks. Yeah. So for querying purpose, for dashboard query, I will explain. This will be quite faster, I think. Yeah.
Yeah. One is the data in, log ingestion, and the rest the log
Yes.
discoverability.
Yeah. Thanks. Yeah. That's absolutely right. So for dashboard queries, like, we'll mention, low latency as low as possible and real time. This is quite real time. So we'll consider there will be no data loss. The reliability of the system will be very high, and the durability. So there are different storage we need to consider here. One is the um, hot storage and the cold storage, right? So in case of we are querying faster, right? So it needs to be um, it needs to be stored for something like, if I will go ahead and consider to use open search or Elasticsearch, the timeline may be something like 15 days. In case of for S3 and other and Glacier sort of storage, I will consider like S3 will go ahead and store for 1 year, 1 month to 1 year duration. And for for compliance and other use cases, like which can be retrieved in the later time, like up to 3 to 5 years. So the consideration will be like Glacier and any other storage, that duration is 3 to 5 years or more. Yeah, I want to check one thing. We usually call this one as cold storage. And okay, is it clear, or does it make sense? Does it make sense?
Can you also mention what data that you're talking about for 25 days? What data you're talking about for 1 month to 1 year, and what data from for 3 to 5 years, to be specific?
Yeah, so for the durability, right? So when I said it is a hot storage, right? The user can query it and see the result as soon as possible. This is applicable to our dashboard queries. Okay, so it could be used for a live dashboard. Okay, so live dashboard, or maybe any sort of critical issues has been generated by the system debugging, live debugging, right? So all these can be considered as a hot storage. I will write it down. Live dashboards. And debugging as well. So usually, the warm storage, the duration is considered. It's again, varied based on the, when you build the system, it depends upon the SLA. So I will go ahead, when I define certain SLA based on, the project severity. So I consider this one as a 1 month to 1 year, but it's, varied from org to org. So this is basically, warm storage basically consider the use case considers compliance, um, if there is regular audit, if it is financial system, okay, so those will fall under warm storage. Periodic audits and complaints. And in case of cold storage, which is for the archival process for multi-year multi-year regulatory or legal sort of use cases. Is it okay? Okay. Anything else? So we need to add. We need to move a little bit fast. So I will, some of the entities we need in these systems are, the actual log. So like it is, logs, and the ingestion job. This is basically, when we are trying to, ingest a job, this is another entity. And what are the different source? Okay, so what are the different source will be the another entity, and the agent as well. So the schema and, the model, the data model for this, entity, I will, explain during the HLD. Okay. So before, before starting the API, I will try to, explain how the Splunk and Neuralink, all these works actually. Okay. So we are going to focus more on that sort of, systems we need to align. So there will be, set of microservices or system. So these applications run in, in our client infrastructure, right? Yeah, one of our app server, okay, where these tools will be, these tools or services are running and continuously generating the logs. These logs are getting generally, getting added into a internal memory, which we called as a, raw.logs file, where the logs are get appended. But before that, the systems get used, we use any sort of utility library. Let's say this is, log4j, where log4j is a library, utility library, which is used to log the, different events. These events are get, stored into the raw.logs file. This is a raw file where the logs get appended. Okay. So the log J4 tools basically use a internal IO stream events for our, general purpose of general read and write operations. The flow will work like this. Okay. So these tools basically, generate the logs which generator runs this tool service and apps all are run in one of our, app servers, and continuously stream the log using the IOStream event and append these logs to our raw.logs file. So here all the logs get appended. So here from there we have an agent basically. So like in case of Splunk, we have an agent called Fluent Fluent probably, and for Splunk we have Universal Forwarder. So these are the softwares which basically runs here.
Sorry, can you repeat that? Fluent bit is an agent for, and universal forwarder
This
is
is
an agent for.
this is an agent for Splunk. Okay, and
The first one,
no,
Fluent.
the first one is the agent for Splunk. Okay, so this one is another agent as part of Splunk also, Universal Forwarder.
Okay, both are the agent for
Yeah.
for
Splunk.
Splunk.
Okay. So when the logs get appended and available in the raw.logs file, okay, the agent is continuously, continuously retrieving these logs from the raw.logs file and send to the systems which we are trying to, discuss now, to their own, own storage. Okay, so we can think of this, this is our app server or my, infrastructure where all the tools are running, and this, this fluent wait and universal forwarder, both the agents are running in the system. These are the softwares which we explicitly downloaded to our infra, and this software basically pull the logs and send to the storage server. This is how typical Splunk and Neuralink, all these log aggregator tool works, right?
One question: this storage server, is it the EC2 machine on which the microservice is running, or is it the Neuralink or Splunk storage server?
Yeah, so this is Neuralink and Splunk storage.
Okay.
So this is an infrastructure. Think like this is your app server where your apps or microservice or tools are running. Okay, and you have downloaded this agent and installed in your app server, and this agent has the capability to pull the logs from the raw.logs. Certain configuration needs to be taken care, but it will it will go ahead and try to pull all the logs which will get appended to this file.
Okay, and the raw.logs file is something which is stored in the microservice server only.
Yeah, it is a system memory actually. Some past, usually var logs we usually use, right? var / logs. We usually keep that one in our infra, right?
Right. So that
So
will
I'll
be in
just
the
pause for a
storage.
moment.
Hmm.
No. So basically, what is happening is the leftmost box, right? So this is the microservice, right? This is the service. This is the service instance where it's a machine, right? This is where your microservice is running, right? And now what is happening is any request that comes in, right? It is writing to a log file, right? It is writing to a log file, and that log naming convention can be decided and configured, right? You might have seen like, okay, let me go and check the logs on that instance, right? So what do? You just log into that instance and then you see those logs, right? And then you might have seen the logs are rotated every hour, right? You see, okay, the request had come at this hour, and you go and cat that file to see the logs in that file, right? So what happens is they do not actually get written into just one file, but the logs gets rotated. So I mean, 1 hour of a file gets written, completed, done. Then the logs starts writing to another file, right? So that's why hourly file gets created,
Yeah,
right?
it's
And then
depend.
there is an agent.
Go ahead. Yeah.
And then there is an agent. What is talking about, right? Fluent bit and universal. These are tied to Splunk, right? So these are the Splunk agents. So these are the ones who are actually reading those files, right? Either pushing those log files, or whatever the logs that are coming to it, right? They are sending it by, let's say, 3 events each, right? Let's say 3 logs came in, and then they have to their pushed to their service, right? To the Splunk service or whatever it is, right? What he's talking about. So these are the agents who are running there. These are some kind of a background processes that are running on that node instance.
So
Yeah.
the
Any
rotation of the
questions?
log is something that we define in the policy of the template. Like if we have prepared some template for the machine, there we define the log rotation policy. So how does this, like this agent, how does it coordinate with that? Like whether it has been able to push the logs to its own source storage server, or have the logs been deleted before it was able to push?
I
Come
haven't
again. So
configured
you
as
are.
such.
So
Sorry,
like
sorry.
log
Go ahead.
rotation, we are moving the we are creating a new file, and we are storing the log file inside the local storage of the machine. But there is also a policy that we want to delete the logs from the particular machine after some point in time. So how does the agent know that these files it has not yet put in its own storage, and it has to sort of read from these set of files and uh, move it to the own storage?
Yes. So your question is like this raw.logs file, right? When we are about to delete, right? There will be certain policy, right? At certain time we need to delete this, logs file. It may be, there will be multiple logs file will be available in this area. So that configuration basically, taken care by the admin itself when they are installing the, agents, right? So there will be some certain configuration they will create, and this hard delete or soft delete, which basically taken care at the client side, right? It is usually, the app owner or, the microservice owner who are running, they usually take care and explicitly specified when they need to delete. So I don't see like, this is where we need to spend much time, but this log file basically, can be deleted, explicitly using, the admin and, the administrator of the system where it is running, or there will be a cron job which can be, set up, which can be set up at the, infra level. The files can be get removed once, all these files get stored into our Flunk storage service.
Okay, understood.
I'll just add one point to it. So basically, there are two things, right? One is the number of days, right? And also you can say that if it has reached to some capacity of the file, right? So there are some designated capacity assigned for these logs, right? So let's say if it reaches 10 GB, so then all those logs will be cleaned, right? So that's how, I mean, older
So
logs will
this,
be cleaned.
yeah. So this policy, this policy again, I'm reiterating, this policy is completely, right now out of scope. But when we set up, in our infra side, uh, it can be, explicitly specified using a cron job, okay, based on the SLA of the system. Okay, so if the system is a financial system having a very critical set of information, okay, we may need to return for certain time, but not very far, because we already creating, we are already storing in our, Frank based storage solution, which is having, all these warm storage, and, for legal we have hot storage, right? So we no need to keep it for long time. And this configuration basically, what I can recall, usually the admin, administrator of the system has set up a cron job, they will go ahead and delete. Okay, so only thing is like they need to be confirmed all the file has been, written. So again, this can be, we can segregate based on the date or application wise, right? Application wise or date wise, correct? These raw logs can be, segregated.
Okay.
Pratik, you want to add anything? You were saying something else, or is it aligning? Yeah.
No, I'm good. I think what you said is correct. Yeah.
Yeah.
Go ahead, Shiv.
So I saw some of type of agents like FileBit and all. They even take care of deletion of the file once they are done with the ingestion. It's like,
Right. Exactly. There are certain agents which also take care. Yeah. So that's absolutely right. Yeah. Mm. Okay. So I will, I will start, capturing some of our API. So one is the agent, agent agent API, right? So the agent so when we are building the systems, we need to get that software download to our infra or app server. So we will go ahead and expose an API for register the agent. So register in the case like this is in the org level registration, right? So if this is Amazon or Apple who are trying to use the Splunk or our tool which we are building, a distributed logging solution, right? So they have to register, and those information has to be stored at stored at our DB, and we will provide a key to them for, with some validity for, 1 year, 3 year based on the license. So this API take care of, registration and onboarding of the client. There will be another API I will consider, like, agents needs to be modified at certain time. Okay. So take an example, like when the license or API key got expired, they can, modify it by again re-registering. So the put will based on that, particular agent ID. So they will pass the agent ID and they will, modify they will extend the license, or maybe, they can change certain configuration which is already stored before. So the put, API will take care of that. And if sometimes, the agent wanted to know the configuration of, already registered agent information, there will be a GET API to get the configuration as well.
Samal, as we had discussed, right? Can you just probably categorize the set of APIs instead of just writing one by one, right? We'll say that agent-related APIs, or let's say ingestion-related APIs, or let's say
It is
source-related
written
APIs.
here
Just
in the top. It is agent, right? API related to agent.
Yeah, high level. I mean, or if you want to really write all of the APIs under each category.
Not
That'll be
really
too much,
required.
actually.
Okay, so some of the key agent is required, required during our discussion. So one API is like, uh, to inform the heartbeat of the, agent, whether the agent is, and the agent is running or agent is died. Okay, so if agent got stopped, right, so the admin has to become explicitly and, restart the agent. Okay, so there will be an API to post and, post heartbeat of the agents. Yeah. So apart from, apart from agent based, data pushing to the system, we will use, some API based ingestion as well, right? So maybe in the interview, we no need to, take care, both the parts. In case of, depending upon the interviewer, whether we are going to, use agent based architectures or, API based directly, pushing the information to our services. So I will go ahead and just, write it down, the API based ingestions as well as, file based ingestion we are going to take care. So there will be, one post API where we will simply, post the logs or ingest the log to our service. And we can, batch the log in case of, offline, in case of the system is offline.
Hey, Shiv, go ahead with your question.
So I have a question here, like the APIs like ingest and batch, right? That I understand that will be on the storage own side, right? And even the registration of the agent, everything will be on that system, correct? But then where exactly the heartbeat API resides, means like it's a are we checking like agent is went down or it's working, or is it like a connection to the centralized system is available?
Yeah, so the agent will post is, heartbeat, whether the agent is live or not. So every time it send a request at certain interval, our server will keep a track of, last timestamp when the agent has, agent was live, right? So if agent has not, responded after that live timestamp, and we can calculate, right? There is a last timestamp minus, current time, right? If greater than, let's say agent is, agent is providing information, their heartbeat information at interval of 30 seconds. If it is more than 30 seconds, we will ensure like the agent is died or the agent is not able to send the event. We will send a critical information through our through our system using notification service to the to whom to the app owner or who are registered, right? So they can come and explicitly register the agent.
So that endpoint resides in the agent. That's what you're saying.
Right.
And that API we are calling from our centralized system to that
Yeah.
agent.
So this API, the agent, it is exposed to our agent, okay, via one of our service, which I am going to be I can say this is like agent registration service. Think like this is agent registration service.
Okay, the first three.
Okay. This all API as part of the agent registration service. Okay, and exposed to our agent, which that software, that tool which has been downloaded and installed here, right? So we will use this API to inform our service what is the status of the agent.
Got it.
Thanks. Okay. The search dashboard will provide a post API to post API for getting the logs at the real time. Okay, and okay, I will if there is any other API required during our HLD or deep dive, we'll come back and note it here, capture it here. Anything anything else we need to add? If I'm missing anything.
Samuel, if you can just explain why we are going with stream processing and then the batch processing as well, just the difference between the two.
Okay. Okay, right. Correct. Okay. So we have, explicitly specified in our functional requirement, we are collecting the logs in the real time. So that will be, we'll go ahead and, use these logs to, stream the content or stream the content in the real time. In case of batch job, right? If the system goes down, right? In case of some network failure or maybe, offline due to some reason, right? We'll store those data in the local DB. Okay. When the system will come online, right? We'll upload that, entire set of, logs or events which have not been captured so far. Okay, using a schedule, we can use a schedule job or any other configuration, that will use that use case will take care of this API. Batch API.
Yeah. And also, right, it also, like in the last session we had discussed, right, the Lambda architecture, that also the batch ingestion also takes care of the data correction, the data accuracy as well. We had discussed the kappa and the
Yeah.
architecture. So just
Yeah,
in case
right.
if any law, anything, right, if there is a mistake, right, so all that will be corrected by the batch flow as well. You'll have
Correct.
to watch the recording from
Yes,
the
right.
previous session.
Correct. Okay. I will start, drawing the boxes for HLD. the clients basically, the clients is the org level. These systems which we are talking distributed logging, we are going to deploy at any org level, right? Enterprise level. The client, I will specify explicitly some examples, like it could be Apple, Apple One divisions, right? Their software division, or Amazon. So they are the client for us, and this is agent, the first service, agent on agent registration service. Again, okay. So the agent registration. So once the infrastructure is set up by the client, they will, they will configure the agent. I mean, they will, just set up, install the agent in their app server, and then the agent will, start registration process. Basically, onboarding the client. So the client information, when the API will get invoked, the post registers, post register, agent register API. The client information will get, stored in the DB. We can, we can use here, Postgres. In the DB is not a challenge here, so we can go ahead and select Postgres, and the schema I will go ahead and try to, capture. The client ID and name and the API. So basically, the API is provided for the authentication for authentication purpose, and then the maybe the time for time frame for the API, or which we can keep as part of the API as well. I will just mention this is API signature. Okay, the client registration table will have the basic information about the client and the name, and the API signature and other metadata. So inside the client, I will try to put the agent here. So this part, hopefully we are clear, right? This is our app server where all the apps and services are available. So the client specific apps, I will explicitly specify client specific app for service. Okay, so the agent will basically read the logs and ingest into our system. I will go ahead and create another service called ingestion service.
By the way, just to add one point here. So the above flow that Shamal has drawn, right, the registration service, this is just one time, right? So all these agents, right? So let's say on behalf of the company, right? Let's say wherever it is, right? So what happens is, let's say for one microservice, they will do the registration, right? And then they will get a token out of it, right? So now if you have, like, let's say n number of services, right? That same token for that company will be used for submitting the logs. This is just one time process just to get the token uh, from, let's say, from these log aggregator services. And then
Right.
after
Yeah.
that, it's the main flow, which is the ingestion flow that he's drawing, right? This is where the logs are pushed continuously with by giving the token in it, along with the logs and the token, so that the
Yes.
log aggregator
The authentication,
is
the authentication process for each client will take care by the agent registration service. So it includes like onboarding as well as authentication, and it will it will provide a response client ID, okay, client ID with API key. Okay, and I wanted to explicitly specified, right? We are not going to be we are not going to focus much about the agent, how this agent basically get created, and the internal internal logics of agents. The agent we need to think of like is a ready-made software which is already available, and we just needs to be set up in our infra. Okay, so then the agent will take care into process all these events, all these API calls, right? So then once this registration successful happened and the authentication succeed, so once the logs are available in our infra side, the agent will start pushing the logs to our ingestion service. Okay, so the ingestion service we can decouple, right? One is for uh, ingesting the real time data. Okay, real-time ingestion service, which will our API based ingestion. We have stream ingest as well as batch, and I will segregate these two services so that so that the decoupling of service load will be minimized. So one is the real-time ingestion service, and this will consider as our batch ingestion. And we can the very simple and no brain idea is to be just store those information in our DB, right? But our DB won't able to handle these sort of loads, right? We are ingesting millions of event per minute, right? So to decouple those live stream event directly writing into the DB, and minimizing the DB load, right? We can offload those events to one of our streaming events tools like Kafka, or you can use AWS managed service if the system is getting built as part of native architectures, Kinesis as well. So I will go ahead and choose Kafka, which is a event stream tool to capture the stream event. And I can segregate the writing of the logs based on the different topics. I will go ahead and create one is go ahead with the raw logs, and we can segregate. We can create another topic to segregate the batch based logs as well.
So guys, this is on the same lines of that Kappa and the Lambda architecture that we had discussed in the last session, right? So if you want to
Yeah, hold on,
record,
Pratik. We have not come yet. Okay. So here you can consider what Pratik is saying as the Kafka and Lambda architectures. So this is basically when we use the event stream Kafka, and we have event stream processor tool called Flink and other Apache based, Spark are available, which will, take care to aggregate the data. But if the system which is already available, some of in my team, some of the tools which is already available to, use for, aggregating as well as, validations, because some enterprise level, some enterprise level tools which is already available, like validations and parsing logic. Okay, so those you can use as part of, different microservices. Okay, if those tools are not available, and those microservices are will be considered as, consumer for the Kafka, right? So here we can, use our own set of microservices. If these microservices are not there, right, so interviewer can, try to, understand, like, because these solutions are out of box and available, everyone we know, right? So we can explicitly specify, if the tools are not available, or, interviewer is not interested to, know those tools, right, to manually aggregating those information, we can go ahead and, select Apache, Apache Flink, which is a ready-made tool, out of box, all these, validation, parsing, okay, enriching the data. Okay, so all these available out of box. So that architecture we called as a, Kappa architectures. So Pratik yesterday discussed that. So, but my point here is, like, we immediately no need to jump, explain the Kappa architecture. Instead, we will give an option. The interviewer will understand, like, yes, that could be another option, right? So we can use our own set of libraries or tools or inbuilt, inbuilt functionality which is available already in our team. If not, right, we can go ahead and try to, suggest this second solution as, Apache Flinks. So definitely the interviewer won't be, agreed, because it is very time consuming to do all these, validation and parsing and normalization those logic. But it's good to be, just explicitly specified. Yeah, Pratik, you were saying something, please go ahead.
No, I mean, on the same lines. I'm good.
And, we'll upload those data to the DB. So here, DB plays a key role, because this is a, a heavy system, as well as, the system in the read side is not that heavy, but, it's depend upon the use case of, use case or criticality of the applications. But we will consider here, okay, I will go ahead and, try to update the NFR as, we'll consider the system as more write heavy than, read heavy. So I will update the NFR is, write is read, right? So one of, popular DB we use basically in case of, a write heavy system is Cassandra, we all knows. So I'm not going to, discuss much about the Cassandra here. So we will explicitly specify, right, Cassandra is one of our, preferred choice here, because of, because of the SS table it has, like, which basically, keep small set of data. Okay, and easily we can, flush the data to our SS table. Okay, instead of, writing, which minimize the, a lot of IO operations, we basically, append to our, we append to our DB, and then flush to SS table, right?
So there are a few terms what Shamal kind of coined. We'll talk Cassandra in detail in further sessions, but in general, at the moment, just remember that Cassandra is a columnar database, and it supports a lot of writes, right? Writes of the order of 10K per second, right? That's what I know of. Prashant, is that correct, or the number is
Yeah, a
greater?
single node can support 10,000 writes per second.
10,000 writes per second, right? So basically the idea is that there are continuously logs coming in, right? So this log DB, what we are considering at the moment is Cassandra. Remember this. And whenever it is a write heavy system, I mean, the normal tendency is to go with Cassandra. Okay, so we'll talk about Cassandra in future sessions, but remember, key point, write heavy, meaning I will have to go with Cassandra somewhere.
Yeah, so it is basically, the append based log mechanism it is underlined, right? So which is, minimize lot of IO operations, right? So there is a concept called write ahead commit log, basically, right? So there is mem table and SS table where, the communication happen, right? So in mem table, they just append it instead of writing, so which is minimize the IO, so which essentially become much more faster, right? And then they cross into our SS table, right? So and there are certain consistency level available, right? And so that might be a separate session we can discuss. The scaling is quite easy based on based on the consistency level we define in case of Cassandra cluster. So in logsdb, right? So Apache Flink can deduplicate and normalize and validate here, right? So based on that, we can store into different table. So we can store into a log label, right? So log label basically the info and the error, etc., right? And we can have a log by trace, which will capture the a different timestamp of the log, right? From which service the data is coming. Okay, and we will have another table, probably the service or application detail, right? From which application and service the data are getting, right? Basically, it will hold the service name and the log date, etc. Okay, so now we are able to ingest the data to our system, right? So here anyone want to point out like what are the area we wanted to improve, like interviewer, what sort of question can come up, right? It is again like we have it again looks like very happy path as well, right? With little bit of enhancement. So what sort of major discussion can happen in this path? Anyone has faced any sort of question here before, wanted to discuss and share here?
I have one query on like how we will partition the Kafka topic, because there can be clients which will be generating a lot of logs, and there can be clients which are generating less amount of logs. So, and we would want the logs of one client to fall in the same partition, I believe.
Logs of one client to be fall in the same partition? No. Okay, yeah.
To
It's a very
maintain
good
the
question.
logs.
Yeah. So okay. So you are saying log of one client you want to put into the same partition, right? So that will okay. So that will create a hot partition problem. It is as simple as that. Okay, so instead of that, explicitly we specify partition based on the client, or maybe any event like day wise or month wise. Okay, instead of partitioning that, we will leave that partition to take care by the Kafka. Let's take care distributing and storing the data inside the partition. So Kafka has that inbuilt functionality. We no need to explicitly specify it based on the clients or any dates or any month. Okay, we need to put the data or put the events, log events to that particular partition. And one more thing, the partition basically, when we create the partition, I think partition is a admin level work actually. Partition does not happen, on go actually, right? On the fly, it did not
Hmm.
happen. Anyone can correct
Correct.
me if I'm wrong. Yeah.
It is configuration based, like you have to configure a topic.
Yes,
Like
Yes,
right.
partition.
So,
it has
so
to
if
be
it is a configuration based,
like that.
right? So again, you need to always, manually increase the partition if you are onboarding a client, right? Right. And if I will explicitly specify one partition to a particular client, right, the hot partition issue will come. If you know that application is it's a Twitter app, right? Let's assume, right? So the Twitter app will have a lot of events get logs, right? So that will create a hot partition to that particular, particular partition for Twitter application. So to avoid all this, right, let the Kafka take care of, spreading evenly the data into the partitions, right? I think this is how it works. If I am,
Okay, so
not able.
it is acceptable that, let's say, some logs arrive out of order,
Mm.
but I mean, to balance out the right throughput is why we are doing this. Is what is it?
Balance out the right throughput. Correct. You were
Okay.
saying to balance out the right throughput, we need to
Like
explicitly.
let's say there is some log for the Twitter client,
Mm.
which was generated at 9:50 p.m.
Okay.
and there were which went into one of the partitions, and some logs which were generated at 9:51 p.m. went into another partition.
Okay.
Due to some reason, the log at 9:51 p.m. got ingested earlier because that partition got
Oh.
cleared faster.
Mm.
So logs
Mm.
can arrive out of order in that case. I mean, they will have the timestamp, but the one with 9:51 will be visible
Yeah.
before the
So
one.
yeah, right. Yeah. So what I can think of here, right? Other can add add their own comment. So I think during the aggregation time, right, this can be normalized, right? Maybe it looks like very simple and normal from my side, very straightforward, answer. If anyone knows, in much details about this, right, they can, put their comments. So based on my knowledge, I think, that, the timestamp, right, can be normalized, in the streaming processing level, right, the Flink level itself.
Yeah.
I know, maybe like, if some better approach is there, anyone can jump in, right? These are the main area we need to discuss. This is a very good question.
I think,
So basically, like, see,
yeah,
go ahead.
yeah. Worship. So I think
Go ahead.
even if the messages comes in out of order, doesn't matter much because we are saying like there will be some SLA, and within that SLA, that message gets available in final elastic DB. I guess that is fine. Means even if it is out of order, eventually all the messages will get in, and whenever the people try to do the query on the dashboard, uh, it will be available. Means you can do the sorting by the timestamp, actual event creation time or event ingestion time. But I think that is okay. If you
Right.
are doing any kind of a transac- transactional or financial job here, I think coming the messages in out of order is okay.
Yeah,
So
in case of there will be some use case like yeah, that's true, because we can provide pagination in our API. They can filter in our API itself. They can sort it, right, sort it based on timestamp or whatever maybe, right. They can got the right order. That's quite possible. Yeah, go ahead. Yeah.
So basically, it's two events, right? I mean, if a earlier event comes later, also, I mean, they are not dependent on each other, right? So, I mean, what it will depend is basically once you draw the schema of the DB, right, it'll be helpful. So let's say there will be one of the keys where timestamp would be there, right? And whenever you're pulling the logs or anything, right, they will be what do you call sorted based on the timestamp as well, right? So let's say there is an event which is of, let's say, 10:23, okay, which came in, and then there can be an event which is 10:18, right, which is by the time it is earlier one, but it got inserted later on, correct? Okay, so it can
Yeah,
happen that way,
yeah,
right?
that's the
But
same
does
thing
not
what
matter.
Steve said. Yeah.
When you're doing the logs, right, it will not really affect anything.
Hmm. Yeah, but what I can think of, right, if it is a critical system, right, if it is a production enabled system and it goes down, there will be some error event log, right? As we are providing a filtering, right, they can filter based on the timestamp and get it order. Okay, but if it is a critical system and somehow filter has not enabled, right, the order is needs to be considered, needs to be considered to be placed, right order, right? Um, right. That will be one use case where it has to be in the right order. But in case we are not exposed to filtering mechanism as part of the API. Yeah. Okay.
Hey, one question on the log DB. The Cassandra, or can we go for something like a document DB? Because this will be more like a file-based one, right?
Aggregating the file and storing the file, right? The Flink can aggregate all the content in a file, right? File one dot log, that is what you were saying. I understood that. File two dot logs, and we will store these files as it is in DB. Correct? That is what you were saying.
Yes, yes. So I was just saying that yes, the database, but should we use the Cassandra, or maybe we can also opt for the Mongo?
Yeah. So yeah, please go ahead.
Yeah, Mongo, what I have read is that internally it uses a B tree for storing the data. And problem with the B tree is that it has to store it in some kind of a sorted order. Now, with Cassandra, like we have append only kind of a storage structure, so it is able to scale up to like 10,000 writes per second. But MongoDB may that kind of a scale it does not provide because of the structure that the data has to be stored in a sorted format. So every time you want to write some new log to the MongoDB, it will have to sort of move the pointer to that particular file storage and then write over there.
Yeah, that probably makes sense. But only thing I was thinking, because the good part here is we don't need really structured data, right?
Yeah, here
So-
what we are doing, Prasant, here, right, in Apache Flink itself, right, it will create a file, right, and it will append all the log based on some enriching mechanism, right, normalization mechanism, right. So when it is one file of let's say one file of 100 MB, right. So that time we can we could MongoDB could be a option as well. Right,
Okay,
right,
we are compressing the logs into a single file, so the number of write operations will be much lower.
right. And this is very much very much real time system usually do actually what he said, the message said.
Yeah, then it makes sense. Yeah.
Yeah, makes sense. So we have let me go back to our functional requirement system able to collect the logs in real time bash. Okay. And it can upload. We have the API and system to be able to validate, parse, normalize, and then create a standard structure and store it. So we have a dashboard to query it. So as it is not that heavy system, what we can do here. So one simple approach is like basically we can have our own service, right? We can use a CDC and dump our data into Elasticsearch, which can do the indexing and all, correct, for quick search. But I think that will be an unnecessary introducing a service. We need to have a consumer service, okay, which basically connect to our DB using CDC. Then the service will write the data to Elasticsearch, right? We can avoid this writing the service and when the Flink will store the data to our, primary DB, right? We can go ahead and, store the data to sometimes the data can be stored in Elasticsearch as well. I got it. Open source. Right? Any other options, like, any other or better approach here? Anyone can provide, like, any better modernization approach?
Sorry, I had got a call. So what you're basically doing is for the search capability, you have put it into an Elasticsearch. So by the way, for people, right? So I mean, OpenSearch is a service provided by AWS, right? Many of you may know. So this is like easy to configure and get it quick up and running. Okay. So Apache Flink is pushing the data to OpenSearch, you're saying.
Yeah. So no,
So it
before this, like,
Mhm.
we can easily, instead of writing from Flink to, open source, right? We can have a CDC, and the CDC can, come on. The CDC can, capture the change data capture can be, easily write to open source by introducing another service. So I think, like, that is an unnecessary service we are introducing. So to minimize that, we can directly, write the data from Flink to open source. But there is a cost associated with, writing a lot of data to open source. We'll minimize that one going ahead, right? Open source is very expensive, correct? To keeping a lot of information per search, that can be minimized. So my question was here, right? Any better approach, right? Anything else anyone has, somewhere discussed? Is feel free to, put their views.
Why not put it into a message queue from Flink, and then the same message gets consumed by the consumer of that log DB and then the consumer of OpenSearch. It can be a pub sub kind of a thing.
Now, you want to add one more event stream tool here, Kafka. Okay, let me see. So you want to add one more event stream tool, Kafka, and from there you want to consume, because Flink has inbuilt capacity to write to open source, right?
Hmm.
I don't see like this is really, why this is required.
I somehow feel because no, they are connected systems, right? I mean, what I'm just little worried is like when two systems are kind of let's say OpenSearch is not responding or anything, right? If it goes down, right, all that can happen, right? So what will happen, right? Flink will be waiting for it, right? I mean, so all those things. So let's say OpenSearch is down, right? Then,
Uh,
or let's say
it, it
or
can be,
your let's say your log,
it can be SAD, right? It can be SAD on top of a cluster, correct?
right? The entire system can go down, right? So then Apache
When
Flink will have to wait until it comes up.
see,
That is one part, and also there will be data loss also, right? Because
no,
we're talking about
data
CDC.
loss won't happen. We have this concept called, yesterday I said, Pratik, right? We can mark that one as part of Apache Flink. It's called, क्या बोला था Pratik? We can.
See, I mean the rate at which Apache Flink is pushing, right, and the rate at which OpenSearch is able to consume, right, they may not be the same that I feel, right? And let's say OpenSearch is like kind of really overwhelmed, right? At that point of time, I feel that it's Apache Flink will be unnecessarily waiting for OpenSearch to acknowledge, okay, yes, I accepted this event, right? That's the reason I kind of feel that between two systems, this should be ideally. And there should be some kind of a broker involved.
Hmm. Okay, the checkpointing, right? Yesterday we were discussing, correct? So no, introducing Kafka is, absolutely fine. I don't see that is a problem, right? But in real-time system, right, introducing the system has, overhead up to maintenance purpose as well, right? So there will be a lot of maintenance needs to be taken care, right? So the only problem here is like, when the open source goes down, right? We can, I have to check again. Okay, I think the checkpointing can be enabled at Flink level to whom it is writing. So I am going to be, enabled, S3 as well for our hot storage, right? So for all these storage, right, I will enable checkpoint. Okay, so one point is clear, right? If open source goes down, right? If open source goes down, that is, very, very, worst case scenario, it will goes down, right? Because all the cluster and everything will bring it up here. Okay, so that time the data is available, but the user cannot see the, the user cannot see the updated data. It is not that the system is completely, completely not operable, right? The system is searchable, but the data is not in the real time. But in our somewhere we have specified it should be, real time, right? It should be in the real time. But based on some SLA, maybe we need to consider, the downtime of some, 3-4 days in a year, whatever maybe. That will be there as part of all the SLA. So even we'll introduce a Kafka here, right? That same set of, issues can come down. Okay. So the Kafka will have a retention of, let's say, 14 days or maybe whatever, maybe like, it will have some data, correct? And if Kafka also goes down, you will have the same set of problem, right? So
So
that
Kafka by default can be configured to have indefinite this thing. Okay, by the way, unlike
indefinite.
Kinesis, yes, indefinite. Kinesis is for 1 year, but Kafka is indefinite, and you can still configure
Indefinite what?
Kafka
Indefinite what? Storage.
indefinite. Yes, indefinite storage in terms of
Yeah.
time.
Yeah.
Okay. So you can configure saying that, okay, let's say 14 days, but yes, any system, right? I mean, let's say open source goes down, it'll be down, let's say for 2 hours, 3 hours in any worst case, right? So you can say, let's say a durability of 7 days for that Kafka, you can configure and then put it there. I mean,
Okay. So coming back to our open source, which is, quite
10 days,
expensive.
okay. After 15 minutes, Amal, right? Quickly finish this, wind it up. Yeah.
Yeah. So
Move
open
quick.
source is quite expensive, right? So what we can do, we can set a TTL here, the TTL of, uh, 10 days, right? So that, we can, make it, effective on the context of cost, right? So we can have a cron job which can be used, to delete the unused log, right? Old logs, right? So I can set up a cron job here, which will basically take care of, deleting the data which is older. So here the same times the Flink is storing the data in S3, so we are able to, manage this hot storage in S3. Okay, we can store that one as part of in our Glacier, right? For cold storage and dashboard and for dashboard purpose, right? We are using the open source, right? So there is one last, a last point where we can inform to our, administrator in case of there is any failed, any error or critical application error or any fail to the agents and all. We can create another topic here, and this topic basically, something like critical alert, which will basically this topic will have a critical alert, right? And so when we'll have a critical alert, we can send our response to, external service. We'll have a notification service, which will alert to, all the downstream system. Right. It will have, two-way arrow probably. You will have the search service, which will, um, okay. Anything I'm missing anyway? Pratik, anyone want to, add anything else?
One question, like, let's say, is it possible that, let's say, the Cassandra cluster goes down and we are not able to write any data to it, like for, let's say, half an hour? And if that is possible, like, how the system handle that use case?
Yeah, to distribute the distribute the logs in or event in Cassandra as well, right? We can enable, the cluster approach, and we can, partition the Cassandra log, and we can create a replicate. Sorry, we can replicate the instances in multiple nodes as well. And in front of Cassandra, I can enable, a load balancer to, take care of, distributing the load across multiple nodes.
Okay, but the Cassandra cluster will guarantee the availability of 100%.
Yeah, the consistency level. So that's why I said, like, we can take a session on, Cassandra consistency level, right? How it guarantee, to
Well, the
ensure,
question
like,
is that he's saying that suppose that partition is there and you're just not able to reach to Cassandra at all. It can happen.
that again, we discuss here that sort of use case, right? We can have the SLA, right? So that will be part of all the system, right? So maybe in a year, 1 or 2 days, the downtime can be defining the SLA. Even that depends upon the critical of the system. When we generate the requirements and the PID phase, right? That discussed based on the criticality of the application. I think that cannot be avoided. The zero downtime sort of question you were asking probably, if I read it clearly. Yeah.
Yeah, I mean, the Cassandra might not be available for, let's say, 4 or 5 days in a year. So
Yeah,
what?
see, again, we can have this, I can enable that checkpointing option. I am writing to S3 and open source for everywhere, right? Apache Flink has a checkpointing. At the last time but we are not losing the, content, right? Okay, so we are not losing the events which has been arrived to Apache Flink, right? The Kafka has ensuring the durability, right? And here I can enable the checkpoint, okay, checkpointing concept for, Cassandra open source as well as S3, right? So in that way, we are not losing the events which has been arrived, but those events probably, not available for some time if any one of the system will goes down,
So we'll have
especially,
to
open
reconcile
source and
data from Kafka to the different systems.
come again, please. Yeah.
We'll have to reconcile the data somehow from the Kafka to the different systems in case any of them goes down. Because all of the data would be durably stored in the Kafka cluster, right?
Right. Yeah. So
If any,
Flink is pulling the data from Kafka, right? So once I will, there will be a certain, memory buffer will be available for Flink, right? Which you can configure, right? So when Flink will not able to, push the data, it will checkpoint there, right? It will say like I'm checkpointing at, 12 o'clock. I'm not able to write any data after 12 o'clock. So when the
Mhm.
system will come up, it will again, write those data. So what is your question here?
Yeah, but I was just pulling out the discussion over there, like how the checkpointing is working. But it is clear
Yeah.
now.
Yeah, I'm not very much, internally clear about checkpointing concept. But what I understood, like it will mark a, time frame, like till that point I have, retained the data to Cassandra, okay, or open source. And after that, the system is not available. You can understand in that way. And when the system will available, it will check the last checkpointing. From there, it will start, writing those data. But internally, maybe we need to check, all the logic and all.
Okay.
I guess it's time to summarize your entire discussion quickly, right? In the interest of time.
Yes. Okay. So, the functional requirement, we have covered, we have completed how to ingest the data from multiple sources. We collected the logs in real time, using, real time ingestion service. Okay. And the Kappa architecture. Okay. And the batch jobs also, we can take care using, using the agents when the system will get available, and the batch ingestion service, which will basically take care to, push the data to our push the data to Kafka. Then we can the Flink will take care to, validate, parse, and normalize the data and store into the Cassandra and other, other set of storage based on the NFR we have defined here. And the dashboard, dashboard query, right? We can able to query the data in the real time, but there will be definitely some SLA, as part of each component, then the system should be able to send critical alert to set up downstream system in case of, there is a critical event has arrived, and the notification service will, stream the events to a respective application. As part of the NFR, we, by enabling the Kappa architecture, the latency can be, minimized. Even, the open source will take care of, querying the latency. We are not able to lose any data because of, we enabled the hot storage, warm, and cold storage. And this is a write heavy system, as we have, specified, as we have mentioned the Cassandra, and based on the data we are pushing, the volume of data we are pushing. Anything
Cool,
else?
done.
Yeah.
Can I stop the recording now?
Yeah, you can stop. We can discuss offline, 1 or 2 minutes.